Hello everyone. I realized today that I didn't record today's lecture, and there's probably some things with standard deviation that doing the calculations tonight would be nice to have an example to go back to. So I figured I would make a quick video here. So this was our standard deviation formula. The y is your data value. The y bar is your mean, and the n is the number of data values. And remember, standard deviation is a calculation of spread. High numbers of spread equate to a large spread, whereas a low number for the standard deviation equates to a low spread. This would be like a cluster of data around the mean, whereas this would be like spread out large, like that would be an example of an overall graph, right? Oops, I did that backwards. Blah. Let's try that again. I could just like start the video over and edit it, but that's not my style. So, no, I did it right. What am I doing? Gosh, that's a large spread. It's very spread out, with the center being right here. There's lots of data spread out. This one is a low spread, so it's a cluster. There's the center, and there's the center, and there's lots of things around the center. Okay. So let's do one calculation together here so you've got an example. So there's my data, 355,814. To be able to figure this out, I need to know the mean before I can calculate the standard deviation. So we want to add all these together and divide by the number there are. In this case, it's 8, 16, 30, 35 divided by 5. Our mean is 7. So when we go to calculate our standard deviation, we're going to take each of the individual values. Oh, I just realized something. I'm a terrible teacher. Like, why do I even have a job? No, maybe I should make these videos when I'm not like high or something. No, I'm just kidding. I'm not high. So I thought I forgot the square. I didn't. I was there. I'm just tired. So let's try this again, right? The mean is 7, so this is going to be 3 plus 7 squared. No, it's 3 minus 7 squared. This is not going well for me. Plus 5 minus 7 squared plus 5 minus 7 squared plus 8 minus 7 squared plus 14 minus 7 squared. And that's all over n minus 1, which in this case is 4. And then once we're done with that, we're going to take the square root of it. So this is 4 squared 16 plus 2 squared 4 plus 4 plus 1 plus 49 all over 4, and we're going to take the square root of that eventually. And then let's see here. That's 20, 24, 25, 74, right, over 4. I'm going to take the square root of that. Man, what's 74 divided by 4? Now I'm starting to test my limits here. Well, 80 divided by 4 is 20. So it's 18 and a half, 18.5. So this is the square root of 18.5, which I'm just going to estimate as like 4.2-ish, right? So that's my standard deviation. What that means is that data values have an average distance of 4.2 units, whatever our unit is, units from the mean. So since our mean is 7, the average distance of these values that we have, their average distance from 7 is 4.2. So notice that the distance from 3 to 7 is 4, right? These ones are less than that, but then this one that's way out here is making that standard deviation go up because it's significantly more than 4. So that one's 4, and these ones are 2, 2, 1. But since that 7 is fairly large, it's dragging that average distance up. Okay, so I thought I would just have that quick video for you guys calculating your standard deviations tonight. And that's all I gotta say. We will see you tomorrow.